Hello everyone. In, in this video, I'm going to discuss on a significant topic which often mislead explorers and geoscientists. Yes, it's about regolith mapping. I try to solve about 4 genuine questions, which will be definitely helpful to develop basic concepts for field geologists. Most of the times, this terminology often comes whoever work in field during mapping. Sometimes we often confused how to distinguish in this especially soil cover region during soil sampling. What are the difference between regolith? By the way, what is regolith? And then what is the difference between soil and regolith in geological context? So, as we see the definition by Regolith 2001, earlier also people come across this. The entire unconsolidated or secondarily re-cemented cover that overlies more coherent bedrock, whatever in situ bedrock above this, whatever material is available, that is called regolith. That has been formed by either weathering, erosion, transportation, deposition. So in situ regolith or transported regolith, both can be distinguished in field, but overall whatever material present above the bedrock, above the in situ rock is called regolith. So it includes fractures and weathered basement rocks, and saprolite, soil, saprolithic rock, those things I'll discuss. Organic accumulation, volcanic material, glacial deposits, column, alluvium, evaporatic sediments, aeolian deposits, groundwater. Everything comes under regolith. It is an umbrella term. According to this standardized definition, regolith refers diversity of material in wide range of geological environments of occurrence. But soil and regolith of course are related terms, but they have distinct meaning and differences. Soil is the topmost layer of the earth's surface that supports plant life. It is a mixture of organic matter, materials, gases, liquids, and living organisms. Soil contains a significant amount of organic material, okay, such as decomposed plants, animal matters, which contributes to its fertility and ability to support plant growth. It is the specific structures, layering, composition that can vary widely depending upon the factors like climate, geology, vegetation, and time. Regolith, on the other hand, is a broader term, it is umbrella term that refers to the layers of loose, fragmented material that covers the soil bedrock. Unlike soil, regolith may or may not contain organic matter. So soil is a component of regolith. It is primarily composed of broken rock materials, minerals. So weathering, erosion, impacts, volcanic activity, typical everything is responsible for development of regolith. So soil, if we see these different horizons, soil is characterized by definitely 6 horizons from top to bottom. Those horizons are required. So there is the difference between paleosol and sediments. For example, in Archean trade, sometimes sedimentary rock and paleosol, this terminology you must have come across. So there is the difference. So regolith, when it is solidified, regolith means it is either transported or in situ. Whatever fragmented material again lithified, that if transportation involved, then that petrification process called sedimentary rock. Whenever that soil profile in situ is preserved, again petrified, that is called paleosol. So these 6 layers comprises of O horizon, A horizon, E horizon, B, C horizon, and R horizon. So these things I will not come into detail. A typical regolith profile may or may not comprise the soil layers, which is also called pedolith. So if we see this terminology must be understood. This is the soil layers. O horizon, that is humus, A horizon, E horizon, B horizon, C, then R horizon. So overall, if we see 3 terminology must be understood: pedolith, regolith, and protolith. So regolith comprises of pedolith, saprolith, and pedolith. Okay, so topmost part is called pedolith. then saprolith, then protolith. These three terminology must be understood. So O horizon mostly form this humus layer in regolith profile. This topmost part from humus. A corresponds to this residuum, that is ferriclerite, calcrete. These kinds of things comes under A horizon of soil, that is called topsoil. E horizon where chemical activity, oxidized zone, those things reached out and go down. This layer corresponds to this portion, motile zone, graduated during pressure. After that subsoil, here the precipitation occur below that water table. Below that sea horizon, this is the very important. Here soil sampling is very important. From here if we see sample, it will reflect lower lying underlying bedrock. So this is the most important zone for sampling to understand if there are any mineralization below the bedrock. So this is this saprolithic portion, saprolith that comprises of saprolite then saprock. This portion is important. Saprolite is chemically relatively altered and in saprock almost equivalent to bedrock particles will be there, and then in situ some fragments is also will be preserved. So this is the weathering layer. Further, this is the standard diagram. It is not necessary to preserve all the things in one locality. And this is a generalized form diagram how gradually with time these types of profiles develop. Different tectonic activity, other superficial activity, all things are involved in creating these things. So that is the importance of regolith. So regolith mapping we see for any mineral exploration from this anybody can say this saprolite part that corresponds to sea horizon, saprolite and sea rock. This portion is important for sampling because it will give overall a broad picture about the rock lying below. However, this upper part, if we take sample, then that is also important. If we understand the geomorphology, then it will be understood that from where this mineral, suppose in this upper part some gold content is high, then it is definitely important because it will be under it overall reflecting secondary halo dispersion. So that dispersion source can be understood from there also. So that is the another importance of this. Now next question is what are the importance of regolith map in exploration? This is a genuine question. In exploration, as I told, as per the geological mapping, one for example I have shown one area here. You can see these types of regolith, these two types of regolith is observed. I'll come into detail how regoliths are classified. For timing it is residual part, then erosional part. For example, here some in situ outcrop was there that could have been gradually weathered and eroded. So erosion means weathering plus transportation. Here weathering remnants left behind. So this is residual level, this is erosional level. To understand that, this topography must be understood. This is the higher elevation. This is gradually sloping part, slope part. Both the side slopes are there. So material will be gradually transported by action of gravity and other superficial process towards this down direction. So it is well established that regolith hosted gold mineralization may also of economic interest. For example, around 82% of the states of Western Australia was from gold mineralization was from regolith hosted. About $63 billion as per the data from Department of Mines and Petroleum record of Government of Western Australia. However, it is also important to note that identification of transported regolith is significant because unlike in situ regolith, transported regolith data cannot provide information on rock below, but it can give you regarding the source area in the possible upstream provenance. So following factors are significant in application of regolith in exploration. Like differentiating in situ versus transported regolith, then the depth of regolith bedrock interference, identification of dispersion pathway. In this identification, drainage concept will also be important. I'll come into that. Intuition of dispersal pathway for target and pathfinder element and the spatial relationship for regolith units. So this knowledge of regolith may be helpful in determining whether the transported regolith completely masks the geochemical signature of the underlying relation. So in the next question, next I'll show. This is the drainage, the same area as I have shown. So from this first order streams come, then it connected to second order, then third order. So second and third order streams are very important. First order is locally restricted. Immediately from source it will come somewhere. Different first order streams will join and form second order. So if anything, any regolith, these are of course domain of erosional regolith. From this residue, whatever material available, it could transport it, and for short time it could settle. Now, so how regoliths are classified? Regoliths are classified based on different scheme. There is a RED scheme by Anand et al. 2001 and 1993. I think. This scheme classified three types: residual, erosional, and depositional. Apart from that, there is another classification, that is GSWA, Geological Society of Western Australia. They have also classified. This is a sophisticated version of Anand. However, practically Anand et al. This classification is more significant because it directly reflects the things reality for a field geologist. It will be most helpful. Here, some terminological ambiguity are involved. So overall, if we see the three regimes of the regolith, that is residual, erosional, and depositional. These three, once we identify, their sophistication further detail exposed, colloquial, situ. There are overlapping terminology. So it is better to broadly use this particular RED classification, that is called residual erosional deposition. That is good enough for field geologist. Now, if we see how RED classification is useful in mapping, naturally, if we see this diagram, this initial phase, how it could gradually weathered and material got transported. This is the at the end. This is the portion left with. So this portion will come under residual regolith. Whatever material could transport it, there will be definitely erosional regolith. As we know, erosion means weathering plus transportation. And depositional regolith will be accumulated in the lowest lying portion. Here is the important also. How it is important. If we see this diagram, you can clearly understand how it is important. Because residue is the feature recognized from the in situ outcrops occur as remnants left behind after profuse mass wasting, weathering, and erosion. Relatively elevated topographic highs as well as isolated outcrops indicate residue. This type of regime is found mostly along this mostly along the elevated ridge portions. Whereas erosional regolith, geologically, it is tricky to identify and distinguish from depositional regolith regime. Erosional regime regolith always lie on sloping topographic plane, unlike the depositional regolith regime, which occur on depressed or horizontal plane. Regional topography as well as remote sensing image or digital elevation model data can be helpful. This is because at certain place, slope changes from steeper to gentler. Relatively thicker accumulation of debris may mislead, as I saw in this portion. This can mislead as depositional regolith. However, in terms of geological time, it should be understood such regoliths are dynamic and cannot be settled permanently. Of course, I cannot observe it is moving on live, but it is definitely under a dynamic process. It cannot be settled permanently. Thus, regolith thickness in erosional regime cannot grow with time, unlike depositional regime. Therefore, if sampling is carried out after digging up from certain depth, for example 1 meter or 2 meter, it will most likely give real picture about rock below. However, depositional regolith is like this. Everywhere it will be lowest lying land and surrounded by high land. So it will be grow vertical. These regolith are characterized by allochthonous nature with permanent settlement in site of deposition over geologically long significant time frame. In this domain, soil sampling cannot provide reliable information about the rocks below. However, in, if we see uh, properly, if we see any toposheet or digital map, you can understand how it is the important. Because sometimes when slightly gentle slope is there, if you restrict within your area, you have to go beyond your area, and you have to see how whether your area falls under lowest flat area or gradually it is also lying at relatively higher elevation. So slope identification is very important, whether it is gentle or steep, or eventually from higher slope it will definitely things will move down slope. So diffusion erosion rate will be varying, but erosion definitely both the cases, whether it is steep slope or gentle slope, it will come under erosional regolith. So diffusional regolith is mainly confined in the depressed portion area where that low lying area is surrounded by everywhere, every direction by higher elevation. Thank you. I hope it will be helpful for anybody who